welcome in a new video. In this video, we will learn some rules to find out the derivative of different functions. So let's start. First of all, the first thing is that if you are going to find out the derivative of a constant number, or you can say that a constant function, then its derivative will always be 0. For example, in order to explain it, let's consider with the help of an example. If you are going to take the derivative of 2, its answer will be 0. Or if you are going to take the derivative of minus 6, as it is also a constant number, or you can say that a constant function, so its derivative will also be 0. Okay, next, if you are going to take the derivative of a variable x with respect to x, then its derivative will always be 1. If you are going to take the derivative of x with respect to variable x, then its answer is 1. Next, if you are going to take the derivative of the function like ax, where a is a constant and x is a variable. So, in order to find out the derivative of the function like ax, the rule is that place the constant on start and take the derivative of the variable include. So its answer will be a, and the derivative of x with respect to x, as we know, is always 1. So its answer will be a. So in order to make it more clear, let's consider with the help of an example. We have to find out the derivative of 2x, where 2 is a constant and x is a variable. So, according to rule, place the constant on start and take the derivative of variable x or the function x. So, as the derivative of x with respect to x is always 1, so its answer will be 2 ones the 2. So, similarly, if you want to find out the derivative of some other function of the type ax, like minus 3 and x, so similarly place the constant on start and take the derivative of variable includes. So the derivative of x with respect to x will be 1, so its answer is minus 3. In this way, you can find out the derivative of the functions like ax. Okay, now if you want to find out the derivative of the some powers of x, like x power n, so here we will use power rule. Power rule states that put the power on start and reduce the power of variable by 1 and take further derivative of the variable x. Power rule states that place the power on start, reduce the power of variable by 1 and take further derivative of the variable includes. To make it more clear, let's consider with the help of an example. You want to find out the derivative of x power 5. What you will do? You will keep in view the power rule. Power rule states that place the power on start, reduce the power of variable. As the power of variable is 5, reduce the power by 1. So its answer will be 5 x power 4, and the further derivative of x with respect to x is always be 1. So its answer is 5x power 4. To make it more clear, let's consider another example. If you want to find out the derivative of x power minus 6. So similarly, according to rule, place the power, as power is minus 6, place the power on start and reduce the power of variable by 1, and further derivative of x with respect to x is 1, so its answer will be minus 6 x power minus 6 minus 1, it will become minus 7. In this way, you can take the derivative of any powers of x, like x power n, where n be any integer. Okay, so next rule, as next rule will be, if we have two functions like f of x plus g of x and both are differentiable with respect to x, so we can find out the derivative of sum of two functions and also the difference of two functions. By the rule, take the separate derivative of first function and also separate derivative of second function. How we can take the derivative of sum or difference of two functions? We can take separate derivative of first function and the separate derivative of second function. So, in order to make it more clear, let's consider an example. We have a function 2x power 4 plus x power minus 1. Consider it is a first function like f of x and this is a second function like g of x, and we have to find out the derivative of sum of two functions. So what is the rule? Rule is that take separate derivative of first function. So we will take separate derivative of first function plus separate derivative of second function. As first function is like the function ax, where 2 is constant and x power 4 is a function. So place the constant on start and take the derivative of x power 4. In this case, as this function can be solved by using power rule. What is the power rule? Place the power on start and take and reduce the power by 1. Reduce the power by 1. Similarly, here we can also apply power rule. Place the power on start and reduce the power by 1. This plus and this minus, it will become minus. X power minus 1 minus 1, it will become minus 2. So 4 2s are 8, x power 3 minus x power minus 2. This is the derivative of our given function, as we can represent the derivative by a single dash. So derivative of given function y with respect to x is 8x power 3 minus x power minus 2. In this way, you can find out the derivative of sum of two functions. Similarly, you can find out the derivative of difference of two functions. Now, if we have two functions, the next rule is that if we have two functions f of x and g of x, and now we have the product of these two functions f of x and g of x, and we want to find out the derivative of product of two functions, and we want to find out the derivative of product of these two functions. So what will be the rule to find out the derivative of product of these two functions? We will use product rule. We will use product rule. This rule states that take the derivative of first function and second function will remain as it is, plus first function will remain as it is, and take the derivative of second function. In order to make it more clear, let's consider an example. We have a function 2x square plus 1 and 3x minus 1. Consider this is a first function like f of x and this is a second function like g of x, and we have to find out the derivative of product of these two functions. So let's apply product rule. Product rule states that take the derivative of first function. Derivative of first function. First function is 2x square plus 1 and second function will remain as it is, plus first function will remain as it is, and take the derivative of second function. Now first function is in the form of sum of two functions. So apply the rule. Take separate derivative of each function. We have taken the separate derivative of each function, and second function will remain as it is, plus 2x square plus 1. This will remain as it is, and now this is the difference of two functions. Now take the separate derivative of each function. Derivative of 3x minus derivative of the constant function 1. Now this first function is in the form of ax, where 2 is a constant and x square is a variable. So according to rule, place the constant on start. Place the constant on start and take the derivative of variable involves, and this function is in some powers of x, plus derivative derivative of the constant function is 0. Now 3x minus 1 will remain as it is. Now this is 2x square plus 1. This function is again in the form of ax. So place the constant on start and take the derivative of x minus derivative of the constant like 1 is 0. Now 2, and this function is in some powers of x. So we will apply power rule. Put the power on start and reduce the power of variable by 1. 3x minus 1 will be as it is. 2x square plus 1. Now 3 and the derivative of x with respect to x is 1, and minus this is 0. 2 2's are 4 and x power 2 minus 1, it will become 1, and 3x minus 1 plus 2x square plus 1. Now 3 1's the 3. Now multiply it to make it more simple. 4 3 the 12 x square minus 4x plus 3 2 the 6 x square plus 3. 12x square plus 6x square, 18x square minus 4x plus 3. This is the derivative of your given function. In this way we can find out the derivative of product of any two functions. Now if you want to find out the derivative of some exponential functions like e powers x, then its derivative will be, our function will remain as it is and we will take further derivative of x. As in the present case, further derivative of x with respect to x is 1. So derivative of the exponential function will remain as it is. Let's consider it with the help of an example. If you want to find out the derivative of e powers 2x plus 1, this is an exponential function, then first the function will remain as it is and we will take the further derivative of 2x plus 1, as there is a combination of two functions. So how we can find out the derivative of sum of two functions? We will find out the separate derivative of each function. Derivative of 2x will be 2 and the derivative of 1 is 0. So our answer is 2e powers 2x plus 1. In this way we can find out the derivative of exponential functions. Now then the next one is that if we want to find out the derivative of natural log of x, natural logarithm of x, then its derivative will be 1 by x and the further derivative of x with respect to x is 1. So derivative of the natural log is 1 by the variable involved. Let's consider it with the help of an example. If we want to find out the derivative of natural log of 2x, then what will be the derivative? The derivative will be 1 by 2x and further derivative of 2x, as this is the form of ax where 2 is a constant, x is a variable. So its derivative is 2x and 2, because the derivative of x with respect to x is 1. 2 will be cancelled with 2, so our answer is 1 by x. In this way we can find out the derivative of logarithmic functions. Now next one is that if we have the function of the type a powers x, where a is a constant and x is a variable. So the formula to find out the derivative of such functions is that take natural log of constant. Derivative of such functions is, first of all, our function will remain as it is, and next we will take the natural log of a and the further derivative of the variable of the power, that is in this case the power is x, so the derivative of x with respect to x is 1. So our formula becomes function will remain as it is and we will take natural logarithm of constant function. Let's consider it also with the help of an example. We want to find out the derivative of a powers 2x, where a is a constant and our power is not a constant. So the rule is that our function will remain as it is and we will take the natural log of constant and the further derivative of power, that is 2x. Derivative of 2x with respect to x will be 2. So its answer is 2, a powers 2x natural log of a. In this way we can find out the derivative of the functions like these. As we have already discussed how we can find out the derivative of different functions. We have discussed how we can find out the derivative of a constant function, how we can find out the derivative of x with respect to x and this will always be 1, and how we can find out the derivative of some powers of x. Also we have discussed the rule, product rule and quotient rule. Now we will discuss how we can find out the derivative of trigonometric functions, some formulas to find out the derivative of trigonometric functions. As you know very well what are trigonometric functions. First of all, let's discuss what is the derivative of sine x. Derivative of sine x will be cos x. And what will be the derivative of cos x? It will be minus sine x. Now what will be the derivative of tan x? We have to find out the derivative of tan x. So to make it more simple, let's discuss it in detail. What is, as you know very well, tan x is equals to sine x over cos x. You can say that sine x is a first function and cos x is a second function, and these two functions are in quotient, so we can use quotient rule. What is a quotient rule? Takes care of the second function will remain as it is, and find out the derivative of first function, and the derivative of first function is cos x. So put cos x minus first function will remain as it is, and find out the derivative of second function, and the derivative of second function is minus sine x. So you can say cos x into cos x, it will become cos square x minus, and this minus it will become plus sine square x over cos square x. as you know the identity very well, cos square x plus sin square x is equals to 1 over cos square x. And you know very well 1 over cos equals to secant, and 1 over cos square x is equals to secant square x. So you can say that the derivative of tan x is secant square x. For a hint, in order to remember what is the derivative of tan x, you can say that tan x in the numerator function is sin x over cos x. What is the derivative of sin x? Is cos x. And what is the inverse of cos? Inverse of cos is secant. So you can say that derivative of tan x is secant square x. This is just a tip to remember, as formula of tan x sin x over cos x, and the derivative of sin x is cos x, and inverse of cos is secant. So derivative of tan x is secant square x. Similarly, derivative of cot x, as cot x is equal to cos over sin x, and in the numerator the function is cos x, and the derivative of cos x is minus sin x, and the inverse of sin is cosecant. So you can say that the derivative of cot x will be minus cosecant square x. Now we have to find out the derivative of cosecant x, as the derivative of cot x is minus cosecant square x. Derivative of cot x is minus cosecant square x. So derivative of cosecant x place minus, as there is cosecant square x. So place cosecant x and cot x. What is the derivative of cosecant x? Minus cosecant x cot x. And now what will be the derivative of secant x? It will be, as the derivative of tan x is secant square x. So write secant x and tan x. These are the derivatives of 6 trigonometric functions.